right, ladies and gentlemen, so today let's talk about lesson 6.4, which is solving systems of equations by elimination. So this is really similar to our last lesson, but now we're just going to take it one step farther. In 6.3, we had simple elimination where we were already set up with opposite coefficients, but for full elimination, sometimes we need to rearrange our equations. So again, we're still working on that same skill of REI 6, solving linear systems of equations exactly and approximately. No new vocab. This is the same term as yesterday, but this time our steps are slightly different. So you can choose to rewrite them or you can just read through them with us now. We need to multiply at least one equation by a constant to get two equations that contain opposite terms. So this is the piece that's different from yesterday. We're going to have to multiply an equation. But then the next two steps are the same. We add them together to eliminate one variable and solve, and then we take that value, plug it back into one of the equations to solve for the other piece. So let's practice with this. What does this look like? Well, when I see this first system here, make sure that you write this in your notes. I see that when I add these two equations together, nothing cancels out. I get 3x and 5x, which gives me 8x. I get a negative 2y and a positive 4y, which gives me a positive 2y, and then my constants. So what I need to do here is I need to figure out a way that I can have things cancel out. And there's multiple ways to approach this. If I wanted to cancel out the x's, I'd have to multiply both equations by a number. But what I see here is I see that my y's are negative in one set and positive in the other, and I can find a common multiple of them. If I take this entire first equation and I multiply it by a positive 2, I'm going to get y values that cancel out. If I take 2 times 3x, I get 6x. Minus 2y times 2 is a minus 4y. And then 2 times 10 is 20. So now if I rewrite this equation, and I'm going to copy over the same one as before, 5x plus 4y equals 24, well now I'm set up for my giant addition equation. When I do that, I get 6x plus 5x, which gives me 11x. My y's cancel out, and I'm left with 44 on the other side of my equation. So the only piece here, the only piece that's new with today's lesson is figuring out how to set up our systems so they're ready to go. And we briefly talked about that with the last lesson where you can multiply by a negative 1 to make opposite coefficients. But this one here, okay, if I keep going now to get x by itself, I divide both sides by 4, or by 11, sorry, and I get x equals 4. Well, now I'm going to go back and I'm going to plug that x equals 4 into one of my original equations to solve for the other piece. When I do that, I get 5 times 4 plus 4y equals 24. And I could have chosen either original equation, but I decided to use the second one because it doesn't have any subtraction in it. If I multiply 5 by 4, I get 20 plus 4y equals 24. Take away 20 from both sides, and I get 4y equals 4. When I divide by 4, I find out that y equals 1. So my final answer for this system is going to be 4, 1. Always have my x value first and y value second. Let's try one more practice problem. If I look at this system here, I have positives on my x's and y's, and I have numbers that are not the same. So I'm going to need to do something to both equations in order to get things to cancel out here. If I look at my x's, I can find my common multiple between 7 and 8, or I can look at my y's and find a common multiple. My common multiple between 3 and 2 is 6, and that's a smaller number, so I'm going to stick with that one. I want to have 6y and a negative 6y. So one of my equations is going to need to be multiplied by a positive, and one of them is going to need to be multiplied by a negative. What I'm going to do is I'm going to make that top one negative. So I'm going to take that entire first equation, and I'm going to multiply by a negative 2. For my second equation, I'm going to multiply the entire equation by a positive 3. Well, when I do that, my first equation, negative 2 times 8x is a negative 16x. Negative 2 times 3y is a negative 6y. Negative 2 times a negative 7 is 14. My next step on my other equation, I'm going to multiply everything by a positive 3. So I get 7x times 3 is a 21x. 2y times 3 is a 6y. And negative 3 times 3 is a negative 9. So now I'm set up for my giant addition equation. When I start to add these pieces together, I get negative 16x plus 21x gives me a 5x. Negative 6y and a positive 6y cancel out. And 14 plus a negative 9 gives me 5. Again, my last step to get x by itself is to divide both sides by 5. And again, I find out that x is 1. I'm going to take that value and I'm going to plug it back into one of my original equations. And again, I'm going to choose that second one just because it's right there, ready to go. Ooh, my line disappeared. There we go. When I plug that in, I get 7 times my x value of 1 plus 2y equals negative 3. Order of operations, I multiply. Using my equation solving skills, I need to take away 7 from both sides. And that leaves me, once I divide by 2, I find out that y is equal to negative 5. Last step again is to plug those pieces in. I have an x value of 1 and a y value of negative 5. So the solution, the one and only solution to this system is the value 1, negative 5. This is the tricky piece here that we added in, that idea of multiplying the equations by a number to rearrange. This is equal, this green equation here is exactly equal to this. If I converted them both into slope-intercept form, it would be the exact same line. But when I set it up this way, I'm ready to go for elimination. Homework tonight, you're going to practice these skills with page 359, numbers 3 through 30, multiples of 3. Good luck.